Then we get to the basement. There were exceptions that if you had a single receptacle for a dedicated piece of equipment, then that receptacle, 15, 20 ampere, 125 volt, did not have to be GFCI. And if there were any receptacles in unfinished basements, and according to the use as you described, Ryan, those receptacles did not have to in the 2005 code. But now, all receptacles in garages, in accessory buildings, in unfinished basements, doesn't matter if they're 15 to 20 ampere, 125 volt, they must be. So this is a big change from the 2005, 2008. If you're experienced doing residential work, you might be used to not having GFCI for those applications. Okay, let's now move on to boathouses. Boathouse receptacles. We're not in a marina, we're just saying a dwelling unit, they have a boathouse, a little receptacle, 15 or 20 ampere, 125 volt receptacle in a boathouse, because it's not outdoors, it's inside of a boathouse. It has to be GFCI protected. Other than dwelling units, all 15 and 20 ampere, 125 volt receptacles in other than dwelling units must be GFCI protected. So basically, bathrooms, right? You know what I'm going to propose for the 2011 code? I'm going to simply get rid of all this A and B, and I'm going to simply say whatever the requirements are in A or whatever the requirements are in B, group them all together. And that's simply all outside receptacles have to be GFCI. All receptacles within 6 feet of a sink have to be GFCI. All receptacles in bathrooms have to be GFCI. You know, all those basic rules, and not having to have a separate rule for dwelling unit, because we're having redundant rules here because this rule is the same thing that's contained in A. All right, let's go to kitchens. GFCI protection for receptacles and other than dwelling units. Well, if you're in a kitchen, a commercial kitchen, Article 100 defines what a kitchen is. GFCI for all of them. That includes receptacles for, let's say, the emergency unit equipment for battery backup lighting. It includes refrigeration and freezing equipment, freezers, convenient receptacles that's dedicated to equipment. This is a big deal for restaurants, because if they lose the circuit protection, I mean, if they lose that circuit because the protection device opens, they're having a lot of spoilage. And Ryan, weren't somebody going to sue you one time when this first rule came out?
That's right. I forgot about that. Yeah, when this came out, I think it was in 2002.
Yeah. Yes,
yeah,
2002.
They had a little fridge that tripped over the weekend that had some chicken in it or something. And,
it was a restaurant.
Yeah, it was a restaurant. It was a smaller fast food restaurant, national chain. But they were going to sue the installer. And they said, well, like, put our fridge on GFCI, and and the installer said, well, don't sue me, sue Ryan Jackson. He made me do it. And I thought, well, sue the state of Utah. They adopted the NEC.
You're saying sue the state of Utah.
Sue the NFPA. Sue Panel 2. I mean,
sue the guy who made a proposal.
Yeah. Sue Mike Johnston. He's the one that put it in, I think. So give me a break. But here's the bottom line, though. I mean, you talk about it, and it's funny and everything, and you're saying, this is a big deal in restaurants if you lose food. You're right, it is a big issue if you lose food. It's an even bigger issue if you lose an employee that touches it and gets killed.
Yeah.
You know what I'm saying? So listen, if your refrigerator trips the GFCI,
and you lose food,
it's time to figure out why did it trip the GFCI. It's not time to figure out who you can sue. You know what I'm saying?
I didn't bring it up, and maybe I should have brought up some slides reviewing the GFCI rules that we talked about in Article 100. And I think what we'll do is when we get done with this, I think I'm going to go ahead and do a little summary and review the GFCI rules. But GFCIs operate about 5 milliampere plus or minus 1. So let's just work with that. Equipment, according to listing requirements, cannot have leakage more than 1/2 of a milliampere. So if a GFCI goes with 5 milliamperes and leakage is no more than 1/2 of a milliampere, what's 1/2 of 5? Is that is that 5%? So I mean, the leakage is only operating at a level at 5%. So there's no reason why a GFCI should be tripping, because appliance is operating properly under its normal condition, unless what? Unless there's a problem that there is leakage and we need to clear it. However, we're in Florida, and in Florida, GFCIs trip simply because of a lightning event outside. You realize that? Lightning striking will trip a GFCI. Also, guys have to be careful with radios in industrial buildings, in commercial buildings, because a radio, you key a radio in, boop, it trips the GFCI, so you have to be careful when you walk by. So there are situations where a GFCI will will open and clear the circuit. Now, if we don't go back to the GFCI rules on how it, the GFCI how it operates, make sure you go into the DVD 1. I would suggest you do that. Stop on that. Go back to the Article 100 introduction. Take a look at the GFCIs because we explain all the mechanisms there. Terry.
Well, the reason this was put in because they did have tests, and that was the reason for the change to put in the GFCIs. You reached on the refrigerator and a guy got killed right there.
Okay, and that's it. All right, let's move on. Here's a receptacle with this is a kitchen. This happens to be my offices, as a matter of fact. And so we consider our little break area to be a kitchen. All receptacles within that serving countertop surfaces in kitchens. All receptacles in other than dwelling units have to be GFCI. Now let's move on to the rooftops. B3, 210.8 B3. All 15, 20 ampere, 125 volt receptacles installed on rooftops must be GFCI protected. I'm guessing if it's a rooftop, it's outdoors, right? So in all receptacles outdoors have to be GFCI. Ryan, you're saying no?
I
not
thought
right?
so too, because I made a proposal to delete rooftops and just add outdoors. And that got rejected because not all rooftops are outdoors. Sometimes on rooftops, they'll have little shed things where you can go in and they have equipment in them. And that's on a rooftop, but it's not outdoors.
All right.
And yeah, I didn't think about it either.
All right, we'll move on. Outdoor, other than dwelling units, any receptacle outdoors, 15, 20 ampere, 125 volt, GFCI protection. That was a change, of course. Other than dwelling unit sinks, any 15 or 20 ampere, 125 volt receptacle within 6 feet of a sink must be GFCI protected. That was a change. Boat hoists. GFCI protection is required for outlets not exceeding 240 volts that supply boat hoists in dwelling unit locations. 2005 code said not exceeding 120. Well, you get an electrician, I got to have GFCI not exceeding 120, no problem. You just take the terminal box open, you take the white wire with the black tracer on it, and you just pull it off of one pin and you move it to the next pin, and now all of a sudden you hook up the motor. It's a 120, 240 volt motor. And now you hook up the motor 240 without GFCI. Obviously, electricity, metal parts, you're in a boat hoist area, wet, water, people, lots of people, hazard, corrosion, high probability of getting injured in an application. And so the key was, it didn't matter if it's 120 or whether it's 240, all of those applications require GFCI protection. By the way, you'll notice this guy was skiing backwards earlier, no problem. Well, he's falling backwards. And for those of you that know me and know a little bit about what I do, I'm a very competitive barefoot water skier. I'm a 5-time national barefoot water ski champion. I won at 88, 99, 2005, 2006, 2007. Hopefully I'll win it in 2008, and there's a high probability. I'm the current national record holder in 2 out of 3 events. I skied the World Championship. I'm trying to qualify for the 2008 World Championships in New Zealand. I'm 56 years old, and I got to compete against the young guys because you have to be the top 20 in the world, and we'll see if I can make it in 2008, make the Worlds. And I'm the oldest skier in the history of barefooting to go into what is called the Open Division, and I did that this year at the National Championship. So it was a very good year in 2007? And last year was a very good year. Well, it's been a very good year. I work. You know what? You can be good at whatever you do. Just keep working at it. And if you want to learn the code and you want to get good at the code, all of us that are standing here, these are all experts. Everybody started knowing absolutely nothing about the code. Eric, you're an electrical engineer. And what did you learn in engineering school about the National Electric Code when you came out? How good were you and what could you possibly do?
Not very much at all. I had one class, power distribution, where, as a matter of fact, we sized a few circuits, and on my midterm, I put the National Electric Code said 2.5-inch conduit. I put down 4, and parenthetically I said, have you ever tried pulling this wire through 2.5-inch conduit?
Because you're an electrician.
Right.
Kevin, but you were in engineering school. What did you learn in engineering school about electric power and National Electric Code?
Well, just the linear circuits classes and power distribution, nothing on the National Electric Code.
We all start from scratch. If you're an electrician, I want you to understand, when that engineer comes out of college, he knows no more about the National Electric Code and really practical electrical at all, anything, than you do when you walk in there for the very first day.